You know, I convinced you it's going to be nice. I was going to print all
You know,
these
she
things
said
for you.
sucks to me. Yeah, I think you said that sucks to me.
All right.
Do you want it written as like in or south?
It can be either one. So now we are going to start doing calculation stuff in this chapter. So it will be a lot of numbers that you've done before, but some new things kind of spread out within it. The first one measures the central tendency. Today we're just talking about ways to find the middle of a set of data. And so the most common things, you've probably heard of all of them, mean, median, mode. Those are really what we look at to try to find the middle of our data. And we have some slightly different notation, just our variables that we're going to call things as we go through. So the first measure of central tendency, when we're talking about those, just that definition, it's any value that finds the center. And the first one we're looking at is the mean. There is a different variable, whether you are talking about the mean of a population or the mean of a sample. If we are talking about a sample, it's called X bar. And it's just you add up all the x's and divide by the total number. If you are finding it for a population, it's called mu. That's a Greek letter. We use a lot of Greek letters in stats. It's like a U with a really long tail in front. And it's the same thing. The only difference is we use X bar if we're talking about a sample and mu if we're looking at the whole population. Okay, so the following data represents travel times in minutes to work for all 7 employees of a startup web development company. So if I'm taking notes, you don't have to write all that, but you need to write down your 7 points. So we want the population mean. Why is this a population? It's all their employees. It said all 7 employees. That's all they have. Okay, so the variable we use for population mean is a mu. Long tail, U. So we just add all these up, and what would we divide by? 7, because we have 7 points. You guys get 24.857? That would have been in minutes. So the average time is not quite 25 minutes. B, take a simple random sample of 3 employees. Compute the sample mean. So if we're talking about sample mean, that's X bar. Sample is the same idea, but we're not dealing with all of them. Did I even tell you which ones to use? No, so pick 3. Give me 3 times. What did you say? 5 and 18? And this time we would divide by 3. And so that sample had an average commute time of 19.667 minutes. All right, so do we know how to find a mean? How do we find the median? What is that? It's the middle. You have to put your points in order from small to large, and the median is the middle. Our notation for that, we use a capital M to represent median. What if it falls in between 2 numbers? What do you do? If my points were 1, 2, 3, 4, 5, 6, the middle is in between 3 and 4. So what do you do? Yep. So it might just be a single number if you have an odd number of points. Otherwise, if you have an even number, you might have to average the ones on either side to find your median. Okay, so let's do the median for our data that we have. So same 7 times, we're going to give our median. Everybody get what they need about this slide. Okay, so the important part is you have to put them in numerical order. So I'll have to recopy my points down, going small to large. So then what's the middle? We have 3 on each side. Okay. Building off this same set of data, let's say we hire a new employee, and I want to recalculate the mean and the median with this new employee. Okay. So my new employee has a 130-minute commute. So now I have 8 points. We have to add that in. So the mean, now what am I going to be dividing by? 8. So if I add all of them up, including my 130, my median what's the median now? What would we have to do?
Add 23 and 26 and divide by 2.
Mm-hmm. And we get 24.5 minutes. Alright, let's compare these to what our values were originally. What was the first mean that we found? 24.57. So our mean went up quite a bit. It went from 24 to 38 because of one person. What about our median? What was it originally? 23. Now it's 24.5, but was there a significant impact? No. Why did the 130 change the mean so much?
Because it's the average.
Right, it's the average. And look at 130 in comparison to all the other numbers. It's much, much larger. Okay, so the mean has some downfalls. If you have a really extreme value, a really big or a really small, it skews your data a lot. You know, if I give a test and I put it in the grade book and somebody's absent and I put in a 0 at the time, it's going to make my average look like my test did not go well. But is that really the case? No, if all the people that took it did well, that one bad score drops the whole average, and then the mean isn't really giving me an accurate picture anymore. The median, it might change a little, but was it a significant change? No. So that's a property that's called resistant. We say something is resistant if extreme values do not affect its value very much. So if you can put in a really big or really small value and it doesn't change it a lot, we say it is resistant. What we just saw, the median is resistant. the mean is not. We talked about the shape of data in the last sections, like skewed left, skewed right, symmetric. The mean and median are kind of going to be related to that. We can see some patterns. When the mean and the median are the same, you have symmetric data. So if you have bell-shaped data, your mean and median are going to be the same or extremely close to the same. But if your data is skewed left, that means we have more low values. So those low values are going to drag your mean down. So if your data is skewed left, your mean is going to be smaller than the median. If you have skewed right, that means you have more high values, so then your mean gets drug up. So if it's skewed right, the mean will be bigger than the median. So you can even just take the mean and median and compare those and know if your data was bell-shaped, skewed left, or skewed right. Use the mean and median to tell the shape of this data we just had. The original set, the mean was 24.87 and the median was 23. So what do you think that means? Yeah, there's not a huge difference, so it's probably going to be close to bell-shaped, but the mean is a little bit higher, so it might be skewed a little bit to the right. If we look at our new data, now my mean is 38 and my median is 24.5. So now the mean is substantially bigger, so it is most definitely skewed to the right. Do we need another example finding mean and median? What is the mode? The mode is the most frequent observation. You might have a couple if you have two different values that both show up 6 times, and that's the most, then that would be, you would have 2 modes. If none of your points get repeated, then you would say we don't have a mode, and that's possible. So you'll always have a mean and median, you may or may not have a mode. In the set of data we've been looking at with the travel times, what was our mode? 23. It was the only one that got repeated. Let's look at 2 examples to finish this up. So if I have a set of data, my points are 11, 15, I don't know that one, 24, 29, and 31. The median is 20.5. I want to find the missing value. So we have 6 points. So the median would be right in the middle of these 2. Correct? So if we don't know it, we could think of it as an x. How do you find the median? And what do we know that has to equal? Okay. So if we multiply over the 2. Subtract the 24. So our missing score was 7. Is that one okay with everybody? The last example I want to do is actually just out of the textbook. If you want to grab your book and look at page 129. Find a friend if you don't have your book. 129.
What page?
129. We're going to look at problem 32. Me too. I'm almost done. Alright, Mr. Zuro finds the mean height of all 14 students in his statistics class to be 68.0 inches. Just as he finishes explaining how to get the mean, Danielle walks in late. Danielle is 65 inches tall. What is the mean height of the 15 students? So I didn't give you the original 14 values. So how am I going to find the mean with 50? So think about how we get the mean. We add up all the x's and divide by our total number, right? We know the mean was 68. So whatever these x's added up to, let's say I just called that x for a second, and that was with the 14 students. So I can't tell what the original values were, but can I find out what they multiplied, or what they added up to? Yeah, if we just multiply over our 14, that sum was 952. So now to find the new mean, we have to do what? Mm-hmm.
Wait, are we finding the mean or the mean?
The mean. So our new mean is 67.8. Yeah. In the problem, that's how tall the student that came in late was, 65 inches tall.
Well, okay.
Are we okay?
No, no clue.
Okay. Where did I lose you?
Can I go get my textbook?
Me too.